Hello everybody, I will start my today another live coding session. So today I solve this question, product of array except self. Given an integer array nums, return an array answer such that answer I is equal to the product of all the elements of nums except nums I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. Okay, it doesn't matter in Python. You must write an algorithm that runs in O(n) time and without using the division operation. Okay, I see. So let me start with clarifying my understanding of this question. So the interface, I will be given the integer array nums. Then I will return an array answer, so which is also the integer array, like this. And these arrays, returned arrays, each element is the product of all the elements of nums except for the number in that position in the given array nums. Okay. So let me check some constraints. So from this, I can say nums length is at least 2. So each number always has the number or maybe numbers except for self. So I can always create the product except self. Okay, for each number. So let me take a look at some examples. So let's say in this case, maybe it's too long. Here, I should return 0. Here, I should return -2. Then here, I should return 0 and 0. Maybe not so interesting because I have 0 here. So let's say I don't have 0. So in that case, here I should return 2. Here I should return -2. Here I should return -1. Yep. Good. And as written is a follow-up, I shouldn't use the I mean, can I solve this question is over? Sorry. So here there's a constraint that I cannot use the division. And here I have another follow-up constraint that if I can solve this question with O(n) extra space complexity. Okay. So I can use the prefix sum or suffix sum for this question. So let's say I want the sum of, say, like, sorry, this one. In that case, the product, the number which should be stored in this position in the returned array should be the product of this -1 and 3, 4, 2. For this one, 3 position, I should get the product of -1, 1 and 2, 4. So the thing is that if I have the prefix product like this, until this, or maybe until this, it helps. Also, if I have the suffix product like until this, or maybe until this helps. Sorry. Because if I try to get the X position, I should calculate the product of this and this. For Y position, I should calculate this and this product. Okay, so I can say build prefix product array, then suffix one, then for each position, calculate and store in the returned array. And finally return this array. Okay, so this is the basic approach. So let me think of the approach so that I can optimize more. So as the constraints, suggest, as this suggests, the output array doesn't count as extra space for space complexity analysis. So I actually can initiate the return array first. And probably I can use this as the prefix product array as first three, like this. So -3, 12, and 24. Yep. Then for this position, I calculated the whole this product so far. So I have to divide this by this number 2. But I cannot use the division operation. Oh no, I see. So I should say before self. So for the first position, I get 1. For the second position, I get -1 only. Then -1 again, and -3, and -12. So in this way, what happens is that for this -12, I get the product until this. So the first 4 numbers product is here. For this -3, first 3 numbers product is here. This one. Yeah. And for -12, it's okay. But for -3, for this one, I have to multiply this product. So I multiply, -12 here. And here, I have to multiply for this position. I have to calculate the product from here to here. So I should multiply -36 here. So basically, I can, do the for loop reversely from tail and keep track of suffix product. Yeah. And in this way, multiply suffix product to that position. Yep, so this is it. Okay. So that's it. In this way, the time complexity should be O band. No. No, true. Yeah. Because I do the traversal twice, and for space complexity, extra space complexity should be constant. Because I don't use any, extra non-constant data structure. Okay, so let me get started with implementation. So I will put 1 first. No, it's fine. If I is equal to 0, I just put 0 here. No, 1 here. Yeah. Otherwise, as I said, as I running, I have to keep track of the prefix, maybe current prefix product. Nums I. Okay, current prefix product. But I do it later because I don't want to include the exact position i's number. So here, I calculate. I just store this. Then multiply by the current number. Okay, so now the first part is done. Next, I do the traverse from the tail. And if I is equal to n minus 1, I shouldn't do anything. Oh, and here I need current suffix prod. So I just calculate. I don't do anything. But if I is smaller than n minus 1, second to last or right before, multiply root I with that number. Then, in the end, current suffix product should be updated. Okay, and I return it in the end. Okay, so let me dry run my code. Let's think of the case, very simple case like 1, 2. So in this case, I should return 2 and 1. So n is 2. So read is now non-nom. And in line 61, this is now 1. Verse 3, I is 0, read I is now 1. So this should be updated to 1 nom. Then in line 76, current suffix prod. Oh, so let me make it 2, 3. I don't want to include 1 here. Yep. The current prefix prod is now 2. Okay. Then in line 65, when n is 1, I is 1, I go to line 69 and read I is now 2 here. Then current prefix prod is updated, but actually it doesn't matter. But it becomes 6. Okay. Now in line 72, current suffix prod is 1, and I iterate reversely in line 73. So when I is now 1, 1 is equal to n minus 1, so I don't do anything. Just update current suffix prod with nums I. It becomes now 3. Then I come back to line 74. And in this case, I is 0. Yep. So I do line 75, which is 3, multiplying 3 to this one. Index 0. So yeah. And then line 77, current suffix prod is updated with 2, so it should be 6. Yep. And I return 3, 2. Okay, so I passed this test case. This is as expected. Good. So I've covered this. I think this is good. Obviously, I need one more case, like 2, 3, 4, because I haven't actually done the multiplication. Check the multiplication actually. But I'm still pretty confident on this because when I add additional number here, current prefix prod or current suffix prod is keep updated, keep being updated. So that being said, I'm pretty confident in my code. So, yep, let me execute. Good. Yep, accepted. Great. Okay, so let me quickly wrap up. So today I solved the question, product of array, excuse me, product of array except self. And in this question, I'm giving an integer array nums, and my task is to return the answer array. And I mean, the element in this answer array is the product of the given array numbers elements, except for the same position. Yeah, in the answer returned array. So for this question, my first approach is to build the prefix product array and suffix product array and iterate each index and calculate the product except self. But yeah, in this way, I could solve this question with O of n time complexity and O of n extra space complexity. But to save the O of n, to optimize the space complexity to O of 1 constant, I firstly put I initiate the returned array and treat it as the prefix product array first. Then in the second pass, I iterate the given array in a reversed order. Then updating the returned array with the suffix product, which should be updated along the way, on the way of iteration, reversed iteration. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.